Okay, Math 10, we're going to be talking about one of the more confusing parts of section 1.5 now. We're going to talk about negative exponents. This always confuses some students, and I don't blame you. It is a little bit confusing. You see the negative sign, you think negative numbers. It actually means something different. So we're going to talk about what do negative exponents mean. We're also going to see what it means for an exponent to be 1 and 0 as well. So we're going to take a look, first of all, at a pattern of what sort of happens as we are having chains of multiplication. So I'm going to use maybe 3 as an example. So let's start with 3 times 3 times 3. So 3 times 3 times 3 is obviously 3 to the power of 3. And that is equal to like 9 if you were to, oh wait, no it's not, it's equal to 27. If you were to multiply it all out, right? 3 times 3 times 3 gives us 27. If we go down a step, if we go from 3 to the power of 3 to 3 to the power of 2, and then 3 to the power of 1, and then 3 to the power of 0, let's look and see what's happening and try to make sense of these numbers. So 3 to the power of 2, let's start with that. 3 to the power of 2 is the same thing as 3 times 3, and that's equal to 9. So that makes sense. That's just the definition of what 3 to the power of 2 is. Let's go down one more step. So 3 to the power of 1. So what is 3 to the power of 1? Well, it's just 1, 3. You're not really doing any multiplying. It's just a single 3. And that's equal to 3. So that's an important one to remember. It's actually one of the exponent rules that we have to keep in mind. Any number to the power of 1 is just itself. It's just going to be, 3 to the power of 1 is 3. A to the power of 1 is A. And we occasionally see that in the questions where they don't have an exponent on there, and you still have to remember there's a secret exponent of 1. So now, what about going to 3 to the power of 0? What's 3 to the power of 0? So 3 to the power of 0, if you're sort of looking at our pattern here, as we go down from one step to the next, what's happening? So when we go from here, when we go from here to here, we're dividing by 3. When we go from here to here, we divide by 3. When we go from here to here, we're going to do that same pattern again, right? We're kind of going down. We're having 1 less 3 multiplied. So again, we divide by 3. So what is 3 divided by 3? It's just going to be 1. And that's another example of exponent law. So anything to the power of 0 is going to be 1. There is one exception, and that is 0 to the power of 0. 0 to the power of 0 is nothing. It's not nothing, sorry. It's undefined. It doesn't actually make sense to take 0 to the power of 0. And I won't go into that in too much detail, but I will post a video to explain why that is. That will be optional for people that are just interested to find out more. Okay, so anyways, as long as you're understanding the pattern and you can see these details, I think things are going okay. So now we're going to go further down. What happens when we do 3 to the power of negative 1? So 3 to the power of negative 1, again, when we go from here to here, we're going to divide by 3. So we're going to divide by 3. What's 1 divided by 3? It's going to be 1/3. So we're going to get 1 to the power of 3. 1 over 3, I should say. Which is sort of like 1, I'll put 1 over like a single 3 going on here. So what we've done is we've created a fraction. When we have a negative exponent, we actually have created fractions. So keep on going down. If we go 3 to the negative 2, again, we're going to divide by 3, which gives us 1 over 9. And that's like 1 over 3 times 3. Do you see what's happened? Like compare this line here, 3 to the negative 2, with this line up here, 3 to the positive 2. Do you see what's going on here? 3 to the power of 2 is 3 times 3. 3 to the negative 2 is 1 over 3 times 3. So 1 is 9 and 1 is 1 over 9. So a negative exponent does not mean a negative answer. It means you've actually flipped it underneath itself. So, my gosh, so much to say. So just here's a summary of sort of what we talked about. So any number, usually people will use a to the power of 1 just equals a. That's one of the exponent laws. And then any number other than 0 to the power of 0 is just equal to 1. And now we have this new negative exponent law that says a to the power of a negative exponent is equal to 1 over that number to the power of a positive exponent. So you can flip your power under 1 to make it go from negative to positive. I don't know if I made that really clear. Let's go do another example. This is just really complicated stuff, not going to lie. Just complicated stuff. I'm going to see if I can... Not sure how to go to like a new space. I'll just press enter a bunch and I'll figure out how to change that later. So moving down. There we go. Okay, I got to a new page. So here's some examples of what I'm talking about. What about something like 1 over... no, I won't do that question first. I'll do one before that. Let's take 3 to the negative 4. So if you had to write this without negative exponents, how could you do that? So basically, that's going to be the same thing as 1 over 3 to the positive 4. There it is. So anytime you want to change a negative exponent and make it positive, you can flip your power. Here's an interesting question, though. What if it was 1 over 3 to the negative 4? Oh my gosh. Now what do? You flip it? It's going to be kind of confusing. So I'm going to call back to the fact that I kind of lost it. But remember, anything to the power of 0 is 1. So let's just reframe this to be, instead of 1, let's write that as 3 to the power of 0. Because 3 to the power of 0 is 1, right? Over 3 to the power of negative 4. Then we can use our exponent laws. We can do the quotient rule, which says that we're going to subtract the exponents, right? So that's going to be 3 to the 0 minus negative 4. And minus negative 4 is the same as plus 4. So that's going to be equal to 3 to the positive 4. Whoa, nice. So the negative exponent, when it's in the denominator, you can flip it to the top to make it positive. When it's in the numerator, you can flip it to the bottom to make it positive. So that's how you deal with negative exponents. A negative exponent is really going to kind of flip its position inside of a fraction. It's not going to make the answer negative. So 3 to the negative whatever it is, let's just say n, is not a negative number. It is just going to be a fraction. It's going to be flipping it. The negative sign is a flipping action when it comes to exponents. So I'll go back to the workbook and we'll take a look. So you might want to read over the workbook and take a look at some of the examples. They have some good examples. Like, I'm not always a big fan of this workbook. There's some things that I don't love, but I do really like these examples. So do look over negative exponents. Take a look at the exponent law itself that's in the box. And take a look at these examples and make sure they make sense. And feel free to ask questions about it on Teams or come and see me in FlexTime. Take a look at this information as well. There's some very sweet, useful pieces of information for you to check out. So there's some good reading. When you actually get to the assignment, I'm forgetting what page that was. I'm going to just jump ahead. Yeah, hey, this is it. So for example, for question 3, you're supposed to simplify and express without brackets or negative exponents, right? So how are we going to deal with that? So this is how you're going to deal with it. For example, B is 5 to the power of 3 to the power of negative 2. So we're going to use our power rule. We're going to multiply those exponents together. So it's going to be 5 to the 3 times negative 2. That's going to be 5 to the negative 6. But then you want to make sure you don't leave the exponent as a negative number. The answer should have only positive exponents. So what does that look like as a positive exponent? You can rewrite it as 1 over 5 to the positive 6. So although these two numbers are equal, like this answer and this answer are the same answer, it's this one that's preferred because it's telling us, don't write the answer with negative exponents. So you're not wrong for the first answer. This one's not wrong. It's just not quite how the answer is supposed to look. So lots of possible questions to ask here for you. So do check these ones out. There's some beauties here. And when I say a beauty, this is like that means it's going to be like a test question, like guaranteed. Like these questions are perfect test questions. I definitely see these in the future being some kind of on a test. I could see any of these questions being on a unit test. So that means they're great practice questions. So I'd love to see you do them. Okay, so that's going to be this question on how do you deal with the negative exponents. I got one more video for you coming up that's going to be about question 4 and dealing with some combining these things together. So check that out in a couple minutes. Thanks, everybody.